What is AI? How does it work? Today's AI journey will take you from learning like a child to mastering the world. Let's begin. In a bustling town of technology, a brilliant inventor named Dr. Innovo dreamed of building an assistant that could learn, think, and help humanity solve its greatest challenges. She called it Aegis, short for Artificial Intelligence Generating Insights and Solutions. Dr. Innovo's journey to bring Aegis to life was guided by several principles of AI. Let's dive into how she made it work, step by step, through a story of innovation and discovery. Ever wondered how your phone recognizes your face to unlock, or how apps tag your friends in photos with uncanny accuracy? Welcome to Topic Guide, where we simplify the complex and dive into the fascinating world of ideas, science, mystery shaping our future. In today's video, we are exploring the magic behind artificial intelligence technology, how machines identify objects with precision, the tech driving it, and its impact on our lives. Whether you're a tech enthusiast or just curious about the science that powers everyday wonders, this video has something for you. So grab a seat and let's unlock the secrets of AI and how it works together. To teach Aegis, Dr. Innovo used 3 methods, like a teacher instructing a curious student. Supervised learning. Dr. Innovo started with labeled data, like teaching Aegis to recognize fruits. She showed it thousands of images labeled as apple, banana, or orange. Aegis learned patterns. Apples were often red and round, bananas yellow and curved. Now it could predict the fruit in new images. Real-world example. Google Translate, which predicts words in a new language using patterns from millions of translated texts. Unsupervised learning. For tougher problems, Dr. Innovo let Aegis explore without labels. It grouped data on its own. For instance, analyzing customer reviews. Aegis grouped comments into clusters like positive, negative, or neutral, without being told what each group meant. Real-world example. Spotify uses this technique to recommend music by finding patterns in listening habits. Reinforcement learning. Aegis became like a gamer, learning through trial and error. Dr. Innovo gave it a reward system. Successes earned points, while mistakes lost them. For example, it learned to control a drone by practicing flight maneuvers, improving every time it avoided crashes. Real-world example. Reinforcement learning powers robots like Boston Dynamics Spot, which navigates tricky terrain. Dr. Innovo modeled Aegis's brain on nature. Neural networks, just like humans, process information through neurons. Aegis processed data using artificial neurons. Layers of learning. Aegis's neural network had layers. Input, layer. Took raw data like text or images. Hidden layers. Analyzed patterns, e.g., identifying shapes or relationships. Output, layer. Gave results like classifying an object or predicting weather. Deep learning. Over time, Aegis learned more complex tasks using deep neural networks with many hidden layers. Examples in real life. Convolutional Neural Networks, CNNs. Helped Aegis process visual data for tasks like face recognition. Dr. Innovo even taught it to diagnose diseases by analyzing X-rays. Recurrent neural networks, RNNs. Aegis learned to understand sequences, like predicting the next word in a sentence. This was crucial for generating realistic conversations. Real-world example. For this, Tesla's autopilot uses CNNs to process road visuals and navigate safely. Next, Dr. Innovo wanted Aegis to understand human language, so she trained it in natural language processing, NLP. Tokenization. Aegis broke sentences into smaller parts, words or subwords. For example, AI is amazing became AI is amazing. Embeddings. It learned the meaning of words in context. understanding that bank could mean a riverbank or a financial institution. Transformers revolutionized NLP. Dr. Inovo used advanced models like BERT and GPT to give Aegis contextual understanding. Now it could write essays, answer questions, and hold conversations. Real-world example. OpenAI's GPT-3 powers chatbots, creating human-like conversations for customer support. Dr. Inovo gave Aegis the gift of sight using computer vision. Aegis could now interpret images, detect objects, and even recognize people. Object detection. Aegis could identify cars, pedestrians, and road signs, a feature crucial for autonomous vehicles. Medical imaging. It spotted signs of cancer in X-rays faster and more accurately than doctors. Real-world example. Google Health uses AI to analyze mammograms and detect breast cancer early. To make Aegis smarter and faster, Dr. Inovo relied on cutting-edge algorithms and hardware. Gradient descent. Aegis used this technique to optimize its learning, adjusting its neural weights to minimize errors. Hardware boost. Specialized chips like GPUs and TPUs allowed Aegis to process massive amounts of data quickly. As Aegis became more powerful, Dr. Inovo realized the importance of ethics. AI systems could inherit human biases if not carefully managed. So she focused on making Aegis fair, transparent, and accountable. Real-world example. Social media platforms like Instagram use AI to recommend content, but they must ensure their algorithms don't amplify harmful content. With Aegis now fully functional, it started solving real-world problems. Healthcare diagnosed diseases faster. Environment predicted natural disasters. Education personalized learning for students worldwide. Dr. Inovo's creation showed how AI could be a force for good. But she reminded the world that AI was only as effective and ethical as the people who built it. AI, like Aegis, is a reflection of human ingenuity and responsibility. By understanding how it works, from learning to deployment, we can harness its power to create a better future.